In this video, we are going to continue to the second example here. So in part one, we have worked out and factorized the first polynomial here. So in this video, which is part two, we're going to continue with the second example. So in that second example, we have got p of x equals to 6x to the power 4 minus x cubed minus 25x squared plus 4x plus 4. Then the possible roots here, according to the rational root theorem, so these are possible rational roots. In the numerator, we're going to list all the factors of 4. In the denominator, we're going to list all the factors of 6, which is the coefficient of the leading term. So 3 and then 6 there. And then we're going to do all possible divisions. So at first, we're going to divide these numbers by plus or minus 1, in which case the numbers are going to come back exactly as they are. So 1, 2, and 4. Then we're going to divide by 2. So when you divide 1 over 2, that's going to give us plus or minus half. Then 2 over 2 is 1, but 1 we already have. 4 over 2 is 2, 2 we already have. Then now dividing by 3, 1 over 3 is going to be, well, 1 over 3. 2 over 3 is going to be 2 over 3. 4 over 3 is going to be 4 over 3. So plus or minus 4/3. Then we divide by 6. So first we're going to have 1 over 6. Then 2 over 6 is 1/3, which we already have. 4 over 6 is 2/3, which we already have. So this is the end of the set. And then we try these. So typically we start with the whole numbers. So if we do p of 1, so that's just going to be the sum of the coefficients of our polynomial. So 1, sorry, it's going to be 6 minus 1, because first one is 6 minus 1, then minus 25 plus 4 and plus 4. Look at the negative numbers is going to be 26. The positive number is going to be 14. So this is not going to be equal to 0. Then we try negative 1. This is going to remain positive. This one is going to change. This remains that, and this one changes. So this time, if you look at the negative numbers and the positive numbers again, you're going to notice that none of them, they're not going to add up to 0. Then we'll plug in 2. So for 2, we're going to have 6 times 2 to the power 4 minus 2 cubed minus 25 times 2 squared plus 4 times 2 plus 4. First one is going to work out to 96. 2 cubed is 8. 25 times 4 is 100. This is going to be 8 and then plus 4. Now, if you look at the negative ones here, that's negative 108. Look at the positive ones. 96 plus 4 is 100 plus this. So this is actually working out to 0. So this is telling us that x equals to 2 is a root, and so x minus 2 is a factor of p of x, so factor of the polynomial. So that means we can divide the polynomial by x minus 2, and it should give us, when we do that, a remainder of 0. So we use synthetic division to do the division. We use that method. So if we bring down 6 and multiply by 2, multiply by 2 again, sorry, this should be positive, and so that is positive. Negative 3 multiply, that's going to be negative 2 multiply, and so the last number is the remainder, and it is 0 as we anticipated. What this is telling us is that we can write the polynomial as x minus 2 into 6x cubed plus 11x squared minus 3x minus 2. Now what you're going to notice is that the constant of the quotient, which is where our focus is going to be now. So if we just let this be our q of x, then the constant is now 2. Leading order term coefficient is still 6. So what it means is that the set of possible roots is just going to change slightly, because so remember previously the constant was 4, so in the numerator this is what we have, but now because the constant is 2, then the numerator is just going to have these 2. Denominator is still going to be the same because we have got a 6 here. So the possible roots now of q of x are going to be in the numerator plus or minus 1, plus or minus 2, in the denominator the same as before. Okay, then this time if we work out of all the possible divisions, of course we're going to start with this set here, because that's what you get when you divide it by 1. Then after that we're going to have your 1/2, 1/3, 2/3, and 1/6. So this is now going to be our set of possible roots. Now going back to the numbers that we tried in P and they did not work, so namely 1 and negative 1. So if these were not roots of P, they cannot be roots of Q now, because Q, if you like, sits inside P. If you like, Q is a factor of P. So we only going to start with 2, because if 2 is a factor of P, it can be a factor of Q as well. So that's where we're going to start now. So if you plug in 2 into Q, we're going to have 2 times 2 cubed times 6, 11 times 2 squared, 3 times 2, this is 2, and then minus 2. This is going to be 48 minus 44 minus 6 minus 2. It's not going to be equal to 0. Then we try in negative 2. So it's still going to be the same numbers. It's just that for the odd powers, the signs are going to change. So this one is going to be negative. This is an even power. It remains the same. So this is what we're going to have now. So what is going to happen is okay, sorry, there is a small error here. This one should be plus, okay, but this still remains non-zero, but it means this should still be plus. So if we take the plus ones, you're going to have 44 plus 6, which is 50. The negative ones, minus 48 minus 2, which is 50 again. So this is equal to 0. So the implication is that x is negative 2 is a root, and x plus 2 is a factor. This is a factor and a root of q of x. So we can divide q of x by x plus 2, or just put the coefficients of q of x here. Then we can use synthetic division to find your q of x and remainder. So from this, of course, the remainder is 0. We expected that. What this is telling us is that q of x we can write as x plus 2 into 6x squared minus x minus 1. So from these coefficients here, then 6x squared minus x minus 1, we can factorize. If you need a refresher on that one, I'm going to post a link to a video for factorizing quadratics. Okay, but it factorizes to 3x plus 1 and 2x minus 1. So then if we take this and plug it back into p of x, then this is what we're going to have. So so p of x is going to be x minus 2 into x plus 2, which is this one, then 3x plus 1 2x minus 1. Then the roots are going to be x plus or minus 2 from these two. Then from this one, minus a third. Then from that one, 1/2. Right. What we're going to do now is we are going to suggest that you have a go at part C, just to make sure that you're understanding this. You can pause the video, and then when you continue it, then you can compare it with our solution. All right, we're now going to scroll down to our solution for part C. Would like to thank you for visiting our channel and for watching these videos. We hope they are helpful. Please do not forget to subscribe and to like the video. And if you've got any questions on the stuff that we're doing, feel free to post in the comments section. All right, so for this one, the constant is 6, and the coefficient of the leading order term is 2. So from the factors of 6, we have the numerator for possible roots from the factors of 2 gives us the denominator. If we do all the possible divisions, we get these 2, 4, 6, 8, 10, 12 numbers. Then we try them out one by one. Here, just trying the first one, we find that it gives us 0. That means x equals to 1 is a root of p of x. And taking this to the other side, it means x minus 1 is a factor. So it means if we divide p of x by this, we're going to get a remainder of 0 indeed. We do this here using synthetic division, and so that tells us that p of x we can write as x minus 1 times 2x cubed plus 3x squared minus 5x minus 6. If we name this q of x, then the focus is going to be on factorizing q of x. Now notice that the constant is still 6. The coefficient of the leading order term is 2. So that means the set of roots is still going to be the same as this one for q of x. So again, we try 1 and find that it is not a factor, a root. Try -1 though, we find that it is a root. So x plus 1 is a factor. Then we divide using synthetic, and then so find that q of x is x plus 1 into this quadratic. We factorize the quadratic, and so this is the factorized version of the polynomial. From this we can find the roots. This one gives us 1, this one minus 1, this one 3/2, and this one -2. All right, thank you.